All right, chapter 5, 1 through 7 is on the first section of the video is 1 through 7. This is part 2. I get from 6th period. Part 3 I do from 7th period. Probably like 6 or 7 problems. And the part 3 will pick up at number 15 because I think it's like 19 or 20 that's got 2 questions to it. It's got 2 little problems to it. Those are the ones, the absolute value inequalities. Which one is it? 18. 19 has got 2 parts, so that's really like 2 questions. But anyway, this one says, which figure has exactly 2 lines? And the idea here is that it says exactly 2 lines. Figure 1 has more than 2 lines. Somebody in my 6th period or 4th period class, 7th period class yesterday got confused about this one because they wanted this to be, they wanted to have it like it said 4. It says exactly 2 lines. So the one that has exactly 2 lines would be that one right there. So figure 4. All right. Remember, when you reflect the line across y equals x, that's what I was talking about earlier, guys. In our warm-up exercise today, it talked about the inverse. We said to test whether or not a function, an equation was a function or not, it was if the vertical line test. Okay, if you do the horizontal line test, that tells you whether the inverse is a function. The way you find the inverse of something is you flip it over the line y equals x. The result of flipping the line over y equals x is that it takes the x's and make them y's and the y's and make them x's. So 3 negative 4 becomes negative 4, 3. See? All right? 9. The coordinates of the endpoint of a segment are negative 2, 3, and 2, 1. Found the coordinates of the endpoint after the translation of, okay, what's going to happen here is you're going to do x equals, or excuse me, x plus 3 to the point negative 2, 3. You're just going to take that and take your x's and add 3. So x plus 3 means take that x. So take negative 2 plus 3 is going to give you 1. And then take the point 3 and go y minus 2. So 3 and y minus 2 is, 3 minus 2 is 1. So you end up at the point 1, 1. And that's by moving, give me some directions here. X plus 3 is going right 3. Y minus 2 is going down 2. So it's going right 3, down 2. Now, we talked about this also. Then what happens to everything else, guys, what happens to everything else is that it gets moved right 3, and it also gets moved down 2. So x plus 3 and then y minus 2 would be 5, and take a y and negative 1. So moving this object from that place to that place is a translation. The word that we've been using for translation, a translation is a slide. Is it a reflection? It's not a reflection. That's a translation. Remember now, what a reflection will do to it is it'll put, it'll put the stuff on the other side. Good? Draw the new image. Remember, the image is where you stop at. The pre-image is where you start at. After a horizontal translation. Good question. Horizontal translation. Horizontal translation is moving in that direction. If you move in that direction, what values do you change? Well, what values do you change? X values. That's right. It's horizontal. That's a horizontal translation. A vertical translation is your Y values. This thing says, draw the image of LM after a horizontal translation of positive 5 and a vertical translation of negative 4. So if I go positive 5, that's 5 units to the right, 1, 2, 3, 4, 5, and 4 units down, 1, 2, 3, 4. So now that point is sitting right there, and so M is in the same place. 1, 2, 3, 4, 5, and down 4. 1, 2, 3, 4. So here's L prime and M prime. L prime, M prime. Is that the image of the preimage? Image. L prime and M prime are the image. That's where it's at. Where it moved from is the preimage. Is it a rotation around J? Yeah, it's rotating around J. I've just pointed on J right there and rotating it around it. Okay, that's the one, guys. That's the one right there that I showed you with. I don't know if you remember the Pixlr picture I showed you. That's the Pixlr picture where it had the picture where I translated it around. I transformed it. That was the word, and then spun it around. That's all that is. And what happens in those situations is that's where it's rotating around a point, and a lot of times they'll let you do that in like PowerPoint or Word or something like that. They'll let you set the center of rotation, and it's the same rotation as the math that we're doing. What happens inside a computer is that there's a program that represents that picture or whatever. Excuse me, there's an equation that represents that picture or whatever, and so when you rotate it around that point, it just sets that point and changes all the x's accordingly. And on a computer screen, they only use the first quadrant. They use the first quadrant, and each of the colors that are controlled or whatever, those are called pixels. So if you see something, a picture is 600 by 800 px. That's what that means. I mean, px stands for pixels, or there may be a picture that's 3 by 5 or something. And when they'll say inches or centimeters or something like that. And in most of the editing programs, they'll let you set all this stuff. But guys, it's that same rotation that we're talking about here. So yes, this is a rotation. Anybody else? All right, identify a single transformation that is equivalent to reflecting the figure across line N and then reflecting the image across line M. So if you're going to reflect it twice, what it's trying to get you to see is that reflecting it twice is the same thing as a translation. Okay, that's what they're asking. Identify a single transformation that is equivalent to figure across and reflecting the image across line M. So you're reflecting it across two lines that are parallel here. So when you reflect it across that one, it kind of turns it backwards. This turns it back around. Guys, that's the same thing as rotating here. If you look earlier in the test, it asked a very similar question. The composition number 7. The composition of two reflections across parallel lines is equivalent to which type of transformation? Number 7, guys, it turns out is pretty much the same question. It's just a different way of asking it. All right. Let me go ahead now, because I got some time here, and work one of these so that I've already got at least one of them worked out. If you want to check the other answers, if you want to check after you work, if you want to check your other answers tonight, they'll both be there. Which, the other one will be in 7th period. So the one I want to work first is this one right here. And remember that we said the deal with absolute value inequalities is all based on, guys, all based on what the original problem says. Because the original problem says greater than 92, guys, you write that greater than 92 on the right. And I tried to get you guys to see that this was a great or problem. That when the original problem has the word greater in it, you know your answer is going to have or in it as well. So on the right, I go 10x plus 10n plus 2 is greater than 92. And what do I put on the left? 10n plus 2 less than what? That's right. Good. Negative 92. Okay. We didn't get, y'all, in here, we didn't work this problem, but hopefully you already have. How many answers did you get to this? 2. That's right. Make sure you get 2 answers. And this problem right here, when I solve, 10n is less than negative 94, so n is less than negative 94 tenths. Or, the word or is going to be in there, guys. And it's all because of this original problem. The original problem is greater than, the final answer is or. Like this one, if the original problem is less than, down here, it'll be less than as well. So 10n is greater than 90. So n is greater than, I guess I should write that up one. 10n is greater than 90. And so n is greater than 9. So I need to reduce this. Let's see, that would be negative 9 and 4 tenths and negative 9.4. So n is less than negative 9.4, or n is greater than 9. When we were going through this, the way I tried to explain this to you is these are the rivers and there's the bank. I want you out on the banks. Stay out of the water. Here's 9.4 to the left, so it's something out here, or it's something over there. It's something greater than 9. So you would pick an answer somewhere in this area below negative 9.4 or above 9. Your answer would not be in this area. It would not be in the water. Okay? That's when it's in between. That's how you pick your answers right there. Okay, sometimes you have absolute values in it. All the numbers below a certain point, they make you get negative answers. And then what's the absolute value of, I don't know, negative 100? The absolute value of negative 100 is positive 100. So right here, when you plug something in, it gives you a positive 100 right there. That's how that works. Yep. Mm-hmm. Right. Yeah, right there, where it starts. The original starting problem sets up everything. If this original starting problem was 10n plus 2 is less than 92, if it was an absolute value problem, then you would set it completely different. I would set it up completely different because of the way the original problem set up. That's what I mean by this greater than. When it's less than, you set it up like this. When it's greater than, you set it up with the word or in it. And so you know that's how your final solution could work.